Wanted to revisit one of these walkie-talkies here, or particularly the charger unit. Actually left this charging today, plugged into the mains, come over, the light's green so it's fully charged, but suddenly I had this realisation in the middle of the day that I wasn't actually comfortable leaving this thing charging, and I was a bit worried I was going to come home and found the house had burnt down. So I think what I wanted to do was convert these chargers to USB powered. The battery itself inside this is a lithium polymer battery, so fully charged about 4.2 volts. Should charge no problem at all off the USB. Looking at the circuitry inside here, and we'll have a look at that in a moment, I've kind of come to the realisation, or for better practices, that these battery packs should have a little lithium PCB in there, a little charge protection circuit. They don't actually look very easy to open, so I don't know how I go about confirming that. I'll have a go at opening one to see whether or not we can get in there. I have a feeling they're probably kind of ultrasonic welded together or something like that. They might just be popped together. No, they feel pretty well put together. Is there any screws under that sticker? No, no screws under that sticker. So there might be a way to pop these open, but we're going to presume that there is a charge circuit in there. No, definitely doesn't want to open. I don't really want to damage it and crack it. Let's take a voltage reading off the top of this battery anyway. So we're reading about 4.1 volts, so just under the 4.2 that would be fully charged, but this one was fully charged. What about the reading off the back here? There's some contacts there. 4.1 volts. Now I did take a reading off the charger itself, and I was reading about 4.7 volts there, and there was still 4.7 volts while it was charging, so there must be a charge protection circuit in there that shuts down the charging inside this battery. So therefore I know that it's safe to give this thing about 5 volts, and that will shut down charging when it's finished charging, when it's fully charged. The other thing that bugs me is the fact that this is unplugged from the mains and has been for about an hour or two now, and that when I plug the battery into the charger the LED lights up. I think that's really bad design really on the designer of this charger. I don't mean to naysay or undermine them on their design, but I would not have done that myself had the LED feed off the battery. So let's have another look inside this charger unit. This will void your warranty, unfortunately, because you do have to kind of take their quality assurance label off there. Of course, anytime you've tampered with anything, that will void your warranty. Some of them are quite meticulous. If you send something back at checking, they'll actually look for things like scratches on the screws to see whether or not someone stuck a screwdriver in there, damaged the screws. Sometimes there'll be some little red blobs of paint or hologram stickers. There's all sorts of methods that companies use to figure out whether or not someone's been inside. Now these were, I've opened one already and it is very well put together, so you don't want to slide and slice your hand, but you get in there and it will pop open with a bit of force. So there we go. Bear in mind the reasons for wanting to do this upgrade. To start with, I thought I was buying USB chargers for these. I was looking on online at various models of this, and all of them showed a picture of the charger with a little USB socket in front. So when I purchased the cheaper ones, I thought that's what I was getting, but they didn't actually show it in the picture. I went back and checked, didn't show USB, and it does say mains charger. So the seller hadn't done anything wrong, it was me not looking properly. First thing that concerns me is that this plug here says fitted with a 13, no, it says fitted with a 3 amp. There you go. And as soon as I take the back off that, you'll be able to see that it is in fact a 13 amp fuse in there, so that's not a good start. The next thing is, well, that just so loose fitting in there that that's a fire risk in itself. What else have we got in here? So, yeah, I was always taught that tinning these wires with solder is bad practice because you get this thing called creepage, which is where the wire actually changes shape from being under compression with solder, and you actually get poor contacts in there. So as someone who's done pat testing before, I would fail it on that. I would fail it on the fuse. I would fail it on, well, they seem okay. They're not too bad. I've seen worse. There's nothing wrong with having a plastic earth pin if it's a correct class of product, but I just hate this single insulation wires on here, so any kind of pinching or damage to this wire is going to result in short circuit, and you can see they're quite well pinched there. It hasn't damaged the insulation. In China or wherever these are made, that might be perfectly acceptable, but as far as I know, all new products should have a double shielded, a double insulated cable on them. Let's just try and get that refocused. Where these go onto the board into the charger themselves, they're just soldered on. Fair enough, it's not great. Got your red and your white wire there, positive and negative. V negative, V positive, it is marked, and neutral and live is marked on there. Funny because they're not colour coded wires. I wonder if they were actually the right way round. Can't check that now. Now bear in mind, any kind of electronic circuit that's been plugged into the mains like this, you make sure it's definitely not plugged into the mains when you're working on it and you've left it to discharge. You should also take care that any large capacitors, and when I say large, this little one here says 400 volts on it. That is what I would consider large. We want to make sure that they're not charged in any way. So sometimes I will just short them out, and if they were charged, you get a big pop of electricity there, and that would have gone into your fingers and given you a nice little blast, woken you up. So looking at the design of this circuit, it's very, very basic, really. There's a little rectifier here, little bridge rectifier or diode. It comes in live negative, yeah, live negative. That then goes into a little transistor. There is a little opto isolator here, and what that does is it reads the output voltage, and if the output voltage drops, it fires this transformer up, and if the output voltage is at the correct voltage, it stops firing off this little transistor here. And in turn, this little transformer, well, we can see there's some isolation here. The board has kind of got a bit gouged out of it, which actually protects the low voltage side from the high voltage side. Gives us a bit of double insulation there. Isolation, it's okay. But here we can see this one component, this little orange transformer, bridges that. So on this side we've got the high voltage side, that side switched. And on the output side we've got a single winding that comes out into two terminals there. 1, 2. Those two terminals move up here to this set of pads, and these set of terminals move over to these set of pads. So again, there's our isolation. This brown bit's been gouged out the bottom of the board. We've got our transformer is here, the orange device, and we've got our primaries on this side, high voltage side, and we've got our secondary winding on this side. One goes up there to this point, the other goes up there to this point. This point here is a little diode. The voltage feeds through to this side. Okay, on the other side, come along here to ground, so that is directly ground or zero reference, and over here we have a little capacitor. And actually, if we didn't know which side was ground marked on the board, we could look at this little capacitor and determine that because this side is negative, it's marked on the capacitor, when we look on this side is negative and that side is positive. Okay, I'm not going to do any probing with this board switched on at all because I do not want to get a shock, basically. This thing could kill me quite easily. Especially with this 13 amp fuse in, although 3 amps is more than enough to blow you away. So what I want to do is make a modification to this board, and the first thing I'm going to do to modify it is get rid of these mains cables. I don't want that mains cable anymore. There we go, gone. The next thing I'm going to do is, if I'm going to put some low voltage over here, 5 volts from USB, I don't want it shorting through this transformer. If I put positive there and negative there, it'll actually go into this coil in the transformer, and that will act as a load, and either the transformer will get warm and draw lots of power from the USB, or it might be so low resistance it will actually just short it out. I can measure the resistance there. I'm going to do that. So set to resistance. The resistance across that transformer is very low, 0.3, 0.2 of an ohms. Let's actually cut this track here. I'm going to just attack this track with a pair of cutters. So if I get my cutters and cut a little gouge out there, if I needed to repair that, I could literally just solder a wire from there to there, but I'm not going to repair it. This is the way it's going to be from now on. I can check that I've cut the track by doing continuity. You didn't see that before, but it was 0.2 of an ohm. Take a reading from there, and I'm still reading some, probably because of the octo note is going up. I would have thought I'd read nothing from there. Oh, I know what I'm doing. I'm reading the resistance through the transformer back to that pad. Okay, but you'll see now that considering it was 0.3 of an ohm, it's now up in the 12k, 13k. If I read between there and this side, we've got some sort of charge-discharge action going on there. I can see it flicking between the two. Okay, so that looks good to me. If I do a short circuit detect, we're not picking anything up. Okay, so that is a high resistance there, which means when I put my 5 volts in, it's not going to just short out my USB supply and fry my USB port. If that was very low, that would just overload our USB port when we connect to it. So I'm happy with that. The last thing I'm going to do at this point is just mark these up so I know which is which. As I'm feeding DC in, I don't really need to even go through that diode. There is a diode there. So I'm actually going to pipe the voltage in here. So this set of pads or circuits there is a positive. I couldn't have chosen a worse pen, and I can confirm that because that is connected to the positive side of the capacitor, and this one over here is negative. All three of these here is negative. Now bear in mind, again, I'm just going to cover safety, we did discharge that cat. But some of these much higher power supplies that you might have with our laptops or PCs and stuff like that, this kind of modification really isn't possible. There are capacitors in there that would blow chunks out your fingers and stop your heart if you're not lucky. So what do we need now? For the next part, I need some form of USB lead that I'm going to butcher and run the wire in. So let's do that. Let's clear some viewing space here. I've got a nice USB lead here. It was a 2 meter or maybe even 3 meter cable. Basically brand new. I've had a couple of these, and the problem is that they just seem to break at this end really easily. If I balance it just right, it charges. If I don't balance it right, it doesn't charge. What a waste of time. What a waste of money. But actually it's going to come in really handy for this project, because I don't want that bit. I will just cut that part off, job done, and then strip this wire back carefully and make use of this. So let's have a look what's inside here. We've got Be careful when you strip these, you almost want to score them all the way around, strip that off. You don't want to damage the wires inside. If we unravel that a bit, you can see we've got this kind of blue foil. Some of them have got some nice strands of wire inside as well. Yep, there's some shield wire, which is this copper wire. This is actually quite a nicely put together cable, because not only have we got shield, they've actually twisted the data cables together, the digital plus and minus. Twisting helps reduce interference down the wire and will increase the speed, especially over a long wire. The shielding is another form of protecting the wire from electromagnetic interference. Let's logically assume that the green and the white is the data and the black and the red are the positive and negative. Now, I would of course never go plugging that straight in without double checking it first. So I will strip some wire off, we'll get the multimeter back in, we'll switch the multimeter to volts, and then what I will do is plug this cable into a little power bank over here, turn the power bank on because it won't come on without a load, and then take the reading black and red, and we've got 5.15 volts. It's going up a bit because it's not loaded. And also note that it is red to red and black to black is giving us a positive reading. If we got a negative reading and we had matched the colours and they were correctly plugged in down here, we'd actually have positive in the black wire and negative in the red. Very rarely come across that, but I have come across it in some cheaper cables. Now, I'm not sure whether that's because inside a USB lead there's actually a crossover. I don't think there is, no. But I have come across some cables where they've put the 5 volts up the black wire. So always double check that. It's worth doing rather than making something go pop when you're actually trying to improve it. So the next thing I'm going to do is trim a bit of those off, and I will add some solder onto these and then get ready to solder them straight to the board there. Okay, we'll bring this in for soldering. Now, how can I position that in a way that makes it a bit easier? Yeah, that will do. I'm just going to pre-tin the black wire. Going to tin the red wire. Then we're going to come over to this charger board. If you're struggling here, you could undo these. They have got a little posi drive on there, but if you're going to do that, do note which one's positive and which one's negative, because I don't believe it's actually marked on the plastic. You would need to draw your positive and negative onto the plastic case there. I'm quite happy to do this in situ. What I will do is solder the red one onto the one I've marked positive. And then the black wire onto the ones I've marked negative. Now I could do with a little bit more solder on that pad, so let's add a little bit of solder down here. Careful that you don't disrupt any of the components or short any of these pads out. It's a bit tricky, but it's definitely not a difficult job. So that's pretty much it then. We've got a USB lead piping 5 volts onto there where that transformer would have been providing 5 volts. So theoretically this should all work now. Oh, guess what I did? I left the USB lead plugged in. Never mind. So that was plugged into the power bank. Luckily 5 volts is not enough to cause any permanent damage or harm to the hand. Say hello to my little friend the diode, or diode. I'm going to add one of these little buggers in here, because I really want to stop that green LED lighting up when the battery is connected but it's not connected to any power, the charger. This little device will allow the current to flow that way. Notice the little white band is on this end, so the current will flow that way, but actually it will stop the current flowing the other way, so it won't flow that way. Forgive my fingernails, I've been in the workshop today. So I'm going to solder that, let's have a look down here, to this tab that has the red wire on it. I'm going to put the band towards the tab, and then I'm going to put the red wire on the other side. Can we get a close-up? Yeah, there we go. Not bad. We'll go that way. So the primary problem with cutting those legs off so short is it's going to get hot. Could probably use some pliers for this job, but that means walking over to the drawer there. Just get that one soldered on. That went on nicely. And then hopefully just solder that one up onto there. Job's a good one. Oh, that one wasn't set yet. There we go. No problems. I guess if you are into conserving your components, there's some components you could harvest off this before you put it back in the box. Your little transformer, I don't know what the ratios are. It's got 2 coils, I think. I'm not really sure how this is configured. I haven't looked into the high voltage side. I just know I don't like it. But yeah, you've got a little power transistor, or it could even be a thyristor there. I'm not sure what it is. A nice diode, a couple of, well, one high power resistor, some quarter watts, another diode. Oh, if you haven't got a diode here, you could take that diode out and use that one instead. That would also work. And your 400 volt capacitor. Nothing that special. What's this transistor here? It is a C33. No, I don't know that number. 59014. Not sure on that one. Okay, but there's nothing really that valuable on there. You really want an opto isolator. Oh, well, I've just ripped that capacitor leg clean off. Well, luckily that won't cause any trouble because I don't like you. Let's just pull that off completely. Oh, come on. One leg just fell off and the other leg is taking the stress and strain. There we go, it's gone. Could pull them all off. There's nothing on that side of the channel there that we want, but I'm going to leave it there. Diode's in. Let's check that that's actually stopped this stupid green light coming on when I put the battery in. Good, no green light anymore. And just before I connect this all up, without shorting it, so I'm going to hold it safely away from everything, I'm going to plug the USB lead back in and just double check that that part is working. So here we go. Could be a up in smoke opportunity here. No, yeah, so you can see the green LED has come on. So we are charging. We're not charging, we're actually full. And that's what I expected, that battery is full. Notice it doesn't make any difference if that's in there. Can you lightly see when I plug it in, I get a slight orange tinge in there. So it's like it is actually pulling a small amount of current in, but not much, not enough to trigger it to be red. You see that? Let's have a closer look. You may or may not see the orange part in there. Noisy multimeter. So yeah, I'm pretty happy that's working. I will have to run the battery down a bit on here to prove that the light actually goes red. I can use my multimeter, which was beeping at me, to test the voltage out to those terminals. Let me prove that. And we're getting 4.8 volts there. When I read that originally, it was about 4.78 volts. So 4.88 volts is close enough for this circuit. Yeah, job's a good one. So all I've got to do now is put that back together somehow. Now the board, I will check that that diode isn't going to short anything. Nope, it's miles away. Got to line that green LED back up. Now bear in mind, I'm running it off 5 volts. If your light's on and you've still got a mains lead, you would get a shock and die right now. But this is low voltage, it's all safe. I'm going to tuck my wire in there. This just kind of like sits in some slots, it's a bit weird. I'm going to tuck my USB under there. I should probably put some form of stress relief in here to stop the wire getting pulled. Shall I do that? Yeah, let's do that. It's good practice. So what will I use for that? That'll work. Just got a little zip tie here. I'll zip tie it around the lead just enough that we can tuck some of the wire inside the charger, and that just allows a little bit of leeway if someone tugs on the wire, that it doesn't just rip it straight off the circuit board. Let's tuck that one in. Really want that one underneath there somewhere, if it will fit. Yeah, it will. And then, I say it will, it does get caught up on something there. Yeah, there's not enough room for the wire to go under the board. It's got to come around. And then maybe I can tuck it around that capacitor. And then maybe we can... Bit fiddly, make sure your LED's in. It's always a pain to get really far and find you've left your LED out, hanging out. So again, just double check the wires are on. There's no shorts. Looks good. The diode is not touching anything. The actual two metal prong contacts, that's the funny thing, is these metal prongs here, we've got these low voltage prongs, they hover over the high voltage side right next to the high voltage components. So, you know, a small crush or some movement going on in here, you could literally make one of these high voltage. I've seen worse power supplies. At least there is isolation between the high side and the low side. My real main concern was this stupid piece of rubbish wire. I wouldn't even use this for low voltage speakers. It's awful. Get rid of that. Plug was pretty bad. 13 amp fuse, sticker that says 13 amps. Let's clip this one back on. Notice I did break a couple of these clips, but it's quite aggressive and there's enough of them left that it should go back on. Yeah, sounds aggressive. There's that one. Clip, clip, clip. The USB lead is firmly in there, and the last thing to do is stick that back in there. And if I'd kept the quality assurance sticker, I could try and stick that back on there, but yeah, I don't think they're going to believe that it's not been off. There we go, good as new, good as new. So I'm quite happy with that. Charger. Throw away the cable, throw away the plug. Send for recycling. I've got the piece of USB lead I cut off that was broken anyway, so that's had a new life. I've probably gone way over the top and got about a 2 or 3 meter USB lead on here now. Let's have a look under it. Yeah, it must be about at least 2 meters. But I would more than happily leave that plugged in charging all day. I'm certain that the lithium batteries inside the walkie-talkie, I've got their protection circuit. I would have had a problem if I'd found that there isn't protection circuit inside here and that the only protection circuit we've got is actually in the charger. But actually, as it comes straight off a 5 volt output from the transformer, as long as we're feeding 5 volts into that, the protection circuitry, if it's inside the charger, should still take care of protecting the battery.